Subscribe to Knowledge Hub, like this video, and tap the bell so you never miss what's next.
Welcome back, deep learning engineers and AI developers. Today, we're diving into one of the most debated questions in machine learning. Which framework should you choose for your next project? If you've been torn between TensorFlow and PyTorch, this video will give you the complete breakdown you need. We'll explore their philosophies, strengths, weaknesses, and real-world applications. Whether you're building production systems or experimenting with new research ideas, understanding these frameworks will help you make the right decision. Let's settle the great framework debate once and for all and empower your AI journey. TensorFlow and PyTorch are the two dominant frameworks powering most of today's AI applications. While both aim to solve similar problems, they approach them with different philosophies and strengths. Think of it as choosing between two excellent toolkits. Both can build amazing things, but your specific project and preferences will determine which feels more natural. In this video, we'll compare their core features, ecosystems, and use cases to help you decide which one aligns best with your goals. Let's start with TensorFlow, developed by the Google Brain team and released in 2015. It's built with production deployment and scalability in mind, making it a favorite among large enterprises. TensorFlow uses static computation graphs, following a define-then-run paradigm. Its comprehensive ecosystem includes tools for deployment, visualization, and mobile support. While it's robust and production-ready, TensorFlow can have a steeper learning curve and more verbose code, which may be challenging for beginners or rapid prototyping. TensorFlow shines in production environments. Its deployment tools like TensorFlow Serving, TensorFlow Lite, and TensorFlow.js make it easy to bring models to servers, mobile devices, and browsers. The API is mature and stable, and it's widely used by major companies for large-scale systems. If your goal is to build robust, scalable AI solutions that need to run reliably in production, TensorFlow is a strong choice. Despite its strengths, TensorFlow isn't perfect. Its static computation graph can make debugging and experimentation more difficult, especially for newcomers. The code tends to be more verbose, and the learning curve is steeper compared to some alternatives. If you're focused on research or rapid prototyping, these factors might slow you down. However, TensorFlow has made progress with eager execution, making things a bit more flexible. Now, let's talk about PyTorch, developed by Facebook's AI Research Lab and released in 2016. PyTorch is known for its flexibility and ease of use, making it a favorite in the research community. It uses dynamic computation graphs, following a define-by-run paradigm, which feels much more like native Python. This makes PyTorch intuitive, especially for those who want to experiment and iterate quickly. PyTorch stands out for its intuitive interface and ease of learning. It's highly favored in academic and research settings because it allows for fast prototyping and easy debugging. The strong research community around PyTorch means you'll find plenty of resources, tutorials, and cutting-edge implementations. If you want to experiment with new ideas or need to debug complex models, PyTorch is an excellent choice. While PyTorch excels in research and prototyping, it has historically lagged behind TensorFlow in deployment and production tools. Its mobile support and industry adoption are growing, but still not as mature as TensorFlow's. For teams focused on deploying models at scale or on edge devices, these limitations might be important to consider. However, PyTorch is rapidly closing the gap with new tools and features. Let's break down the key technical differences between TensorFlow and PyTorch. The most fundamental distinction is how they handle computation graphs. TensorFlow traditionally uses static graphs, where you define the computation first and then run it. PyTorch, on the other hand, uses dynamic graphs, building the computation as you go. This impacts how you write code, debug, and experiment. Both frameworks now offer more flexibility, but their core philosophies remain distinct. Let's look at a simple code comparison. In TensorFlow, you typically define your computation graph up front, then execute it. In PyTorch, you build the computation as you run your code, making it feel more like standard Python. This difference affects how you debug and experiment. PyTorch allows you to use standard Python debuggers, while TensorFlow has its own tools, though eager execution now offers more flexibility. When it comes to learning, PyTorch is often praised for its gentle slope. It feels like writing native Python, so if you're already comfortable with Python, you'll pick it up quickly. TensorFlow, on the other hand, introduces more concepts up front, making the initial learning curve steeper. However, once you're familiar, both frameworks offer powerful tools for building advanced models. TensorFlow boasts a comprehensive ecosystem. Keras, now fully integrated, provides a high-level API for building models quickly. TensorBoard offers powerful visualization tools, while TFX supports end-to-end machine learning pipelines. TensorFlow Lite and TensorFlow.js make it easy to deploy models on mobile devices and in browsers. TensorFlow Serving streamlines model deployment in production environments. PyTorch's ecosystem is rapidly expanding. Torch Vision, Torch Text, and Torch Audio provide specialized tools for computer vision, natural language processing, and audio tasks. PyTorch Lightning simplifies training workflows, and TorchServe enables model serving. PyTorch Mobile brings models to mobile devices, making the framework more versatile for a variety of applications. Both TensorFlow and PyTorch have strong communities and excellent support. TensorFlow is backed by Google and has widespread industry adoption, while PyTorch is supported by Meta and is the favorite in academic circles. Both frameworks offer extensive documentation, tutorials, and active forums, making it easy to find help and resources. TensorFlow is widely used by companies like Google, Uber, Airbnb, and Intel for large-scale production systems. PyTorch, meanwhile, is gaining traction in industry, with adoption by Meta, Tesla, Microsoft, and OpenAI. Both frameworks are actively maintained and updated, ensuring they stay relevant as the field evolves. In terms of training speed, both TensorFlow and PyTorch are generally comparable for most tasks. The actual speed often depends more on your implementation and hardware than on the framework itself. Both support distributed training and GPU acceleration, making them suitable for large-scale deep learning projects. Both frameworks have similar memory footprints and offer memory optimization techniques. In some cases, PyTorch may be slightly more memory efficient, but the difference is usually minor. For most applications, memory usage won't be a deciding factor between the two. TensorFlow is optimized for production inference, with mature tools for deploying models at scale. PyTorch is catching up quickly, thanks to TorchServe and ONNX support. TensorFlow still leads in mobile optimization, but PyTorch is making significant progress in this area as well. When it comes to model size, both frameworks are comparable when using similar architectures. They both support quantization and pruning, which help reduce model size and improve efficiency. TensorFlow Lite offers advanced optimization for mobile devices, making it a strong choice for edge deployment. For most real-world applications, the performance difference between TensorFlow and PyTorch is negligible. Developer productivity and familiarity with the framework often matter more than raw performance. Ultimately, your choice should be guided by your specific use case and team expertise. Choose TensorFlow if you're building production systems that require robust deployment, especially on mobile or edge devices. It's also ideal if your team already has TensorFlow expertise, or if you need to use TensorFlow-specific tools like TFX. Enterprises that need strong support and scalability often prefer TensorFlow for these reasons. PyTorch is the go-to framework for research, rapid prototyping, and experimentation. If you prefer Pythonic, intuitive code, and need easy debugging, PyTorch is a great fit. It's also ideal for academic settings and for accessing the latest research implementations. As PyTorch's deployment tools improve, it's becoming more viable for production as well. Both TensorFlow and PyTorch are excellent for computer vision, natural language processing, reinforcement learning, and general deep learning applications. The frameworks are converging, with TensorFlow adding eager execution and PyTorch improving its deployment story. Knowledge transfers well between them, so learning one helps you pick up the other more easily. If you want to learn TensorFlow, start with the official tutorials and guides. The Coursera Deep Learning AI specialization is highly recommended, and the TensorFlow documentation is thorough and up-to-date. Books like Hands-on Machine Learning provide practical, project-based learning to help you master the framework. For PyTorch, the official tutorials are a great starting point. Fast.ai courses offer hands-on, practical learning, and the PyTorch documentation is clear and comprehensive. Books like Deep Learning with PyTorch provide in-depth coverage and real-world examples to help you build expertise. The good news is that the core concepts of deep learning are the same across both frameworks. Syntax differences are learnable, and experience with one makes it easier to pick up the other. Many concepts also transfer to other frameworks, so investing time in either TensorFlow or PyTorch will benefit your overall AI development skills. PyTorch is rapidly gaining industry adoption, while TensorFlow remains strong in production environments. Both frameworks continue to evolve, with interoperability improving through tools like ONNX. The landscape is dynamic, and both frameworks are excellent choices for modern AI development. If you're just starting out, PyTorch offers an easier learning curve and feels more like native Python. If your focus is on deploying models in production, TensorFlow's mature deployment tools make it a solid choice. Ultimately, both frameworks are excellent, and learning either will serve you well in your AI career. Researchers will find PyTorch to be the current standard for experimentation and prototyping, thanks to its flexibility and ease of use. Production teams, on the other hand, may prefer TensorFlow for its mature deployment tools and enterprise support. A hybrid approach is also possible. Research in PyTorch, then deploy with ONNX or TensorFlow as needed. Ultimately, the best framework depends on your project requirements, team expertise, deployment targets, and personal preferences. Both TensorFlow and PyTorch are excellent choices, and learning one makes it easier to learn the other. The fundamentals of deep learning remain the same, regardless of which framework you use. Focus on understanding the core concepts, and you'll be well equipped to build great AI solutions.
Subscribe to Knowledge Hub, like this video, and tap the bell so you never miss what's next.